Hello everyone, in the first module, which is going to be about computer networking for a web developer. So the objectives for this module is going to be to understand what is computer networks. You may know what is computer network. Feel free to skip if you are familiar with most of the topics here. But I just wanted to make sure that all the students have the foundation or the basics of how computer networking is done. So the second objective is going to be to understand the foundation of communication systems, understand the domain name systems. It's really important for the web developer to understand how does domain name systems are structured. Chain and network connectivity is another skill that a web developer needs to understand, as like most of the time when a web developer try to develop the application or try to reach one of the applications that he built, for example, and he couldn't do it, what's the problem? He has to understand what's going on. Another skill that a web developer needs to understand, which is tracing communication, how to trace like a packet or a request going out from your PC to designated server, how to trace it, to understand where the problem is. Because in most cases, if you are a web developer, the end user is gonna just talk to you, I have a problem. What's going on? I cannot just like log into my system. What's going on? As a web developer, you have to understand where is the problem. If you are not able to understand where or to locate where is the problem, then this might be like a problem for you. It might take a lot of time to figure out what's going on with your system. So let's start with what is a computer network. Let's just imagine this analogy. If we have two people are talking to each other, usually we call this networking of two people because it's requirement that there are at least two people. If we have 3 people, 4 people, 5 people, then we are saying it's networking, right? If like more than 2 people, or let's say 2 or more people are engaged in the conversation, we call it they are networking. So to be able to communicate with each other, like if let's say 2 human, they have to let's say talk to each other. You cannot just like someone talks to a tree, because the communication system for let's say for the tree is completely different than the communication system for a human. So human have to talk, or let's say human has to talk to another human to be able to transfer or transmit some data or make some communication. So to be able to, let's say, transmit your voice, we have to have some medium. So if, let's say, we have 2 people in completely isolated rooms, and they cannot just hear to each other, then we cannot say that we have networking, because we cannot just like convey the message from one human to another human. So the voice here, or let's say the space, is the way that our voice is deliverable from human A to human B. The same thing we have in computer networking. So when we say like we have 2 or more people are talking to each other, that means we have 2 or let's say more computers communicating to each other. When we say a common language, or they have, let's say, a common system, or they have the same communication system, then we're saying that we have the same communication model. These are like the terms that we have to understand in the computer networking. When we say like the voice delivery, we are talking about network medium, how the data is going to be transferred from computer A to computer B. So in general, the internet is group of connected networks. So for example, At your home, you may have this network. You may have your PC, you may have your laptop, you may have your, let's say, cell phone, are all connected through your router, which is provided to you by your ISP. And your router is directly connected to your ISP or the internet service provider you have. Let's say you are connected to, or let's say you are subscribed with AT&T, then your router here should be connected to, let's say, AT&T gateway or ATN router. So we have here AT&T. AT&T are, let's say, is connected to another network here, which might be a different ISP or might be a different networking. And here is another company, let's say google.com, and we want to reach to, let's say, their website. So in this case, if you are on your laptop here and you type in your browser google.com, so your request is going to be go from here, and it knows, since like all these routers know how to navigate or how to deliver your message to the destination here, then it's going to be moving this way, then it's gonna come back. It might come back to you like using the same path, or it might have a different path. So let's say here I have this simulation here for you to see like in action how does your data, or when you are trying to type something on your laptop, how does it go, how you are like reaching to this destination. So let's say in this laptop here, I'll try make sure that we are on simulation here. So in this laptop, we are going to go, by the way, this is not required for you to understand what's going on with it, but it's important. I just like want you to see how these information are transmitted from one place to another. So I have this server here, which is a web server. Its address, I'm going to type it here. It's 10, 10, 7, and 1. And I wanted to just like, this is what you do with your browser. You type the domain name, and we will later understand how does it work. But for now, let's assume that this IP here is a domain name. So when you click and go, let's try to see what's going on. So here, it's gonna go to the switch. It's gonna go to the home router. So home router knows that if, let's say, the message is sent to someone that he doesn't know, then he will forward it to someone else, which in this case, it's gonna be for your ISP. So in your ISP router should understand and should know how to find the destination. As you can see here, as you can see, it's reached now to the server. If you see here, we haven't been able to see anything yet here. So let's carry on here. Now the request is done. Now the response will start. Since I only have one path here, then it's gonna just go back from the same path that it came in. As you can see here, if we just like turn it to real time, you would see the content of this web page. So your request might go through like multiple hubs. When we say hubs, we mean how many routers that your request has been through to reach to the final destination. This is like a quick demonstration how your request, how the networking is like done. As you can see, this one is just like one network, This is another network. This is third network. This is fourth network. So the whole internet is about, like, let's say, just a network of connected networks. I hope this like helps you to understand what's going on with networking. So the communication models. Model communication models use something we call layered stack models. This layered stack model gives us like the following advantage. First and foremost is the simplicity. When we say the simplicity, we are talking about the architecture. It's easy like to create, let's say, any device specialized for any layer. For example, let's say when we are trying to design a specific router, vendor might just like go and understand just the protocols and the standards that work for layer 3 and just like build the device for this layer. When we are talking the simplicity for the learning, it's really easy for the students to understand how the packets or how our data is transferred from one layer to another. So another advantage is modularity. When we say modularity, we are saying that I can just like, let's say, target one layer for my own development, or I can just like, instead of redo the whole thing, if I want to develop one of, let's say, protocols or something, I have to just like go with the specific layer, as we will see in a moment. Modularity leads to easier development, as we will see what happened with OSI and how TCP/IP communication model has been proposed based on OSI. Interoperability, it's another important stuff which makes like, let's say, the vendors be able to build their own system and make sure it's working fine. So let's say company A, for example, they are specialized in building network cards. So all they need to understand is how and like what kind of standards that works for this specific layer and how to communicate with the upper or lower layer. When we say communication model, one of the most common communication model, by the way, this is like you would find people call it reference model. Most of the time, no one's gonna use this model, but it's just created for a reference purposes. So when we say layered, that means this layer has its own objectives and its own protocols. So this is the first one, which is application, presentation, session, transport, network, data link. Let me just like disable the pointer here. So data link and the physical. So on the application layer, these are like the application protocols that we are using. For example, when you're trying to reach a website or when you are trying to access your email address, you are using one of the protocols provided by or work on this layer, for example. When you have your own data and you're sending your data to another device might not be the same, let's say, operating system, might not be the same computer, might not be, let's say, have some restrictions. How to make sure that the data you are sending, it's readable in the right way on the destination. So for the session layer, we are establishes the ends, like the start and ends, the connection between two hosts. It keeps like the session ID, keeps all these stuff together. So transport is like really important to understand, and we'll have more discussion about the transport. But for this layer, it's important to understand what kind of mechanism you are trying to use. Do you need like faster communication or more reliable communication? These are like some of the trade-off that a web developer should understand when they build their own web application. When we are talking about network, it means like how to choose the best path that to deliver your message from computer A to computer B. Okay, most of the time we call this routing. So in data link, how to access the medium, when to access the medium, are you allowed to access the medium? These are the things that it's been standardized to be part of data link layer. On a physical layer, you are sending the data, or this is like the actual transmission bits. It's done on this layer. When we talked about the modularity and when we talk about the simplicity of architecture and the easiest, or let's say how to develop your own model, this is one of the things that we are all using these days. TCP/IP is like the one that most computers these days are using. In fact, this communication model is built on the top of OSI. So since OSI layer, as I said, it's layered stack communication system, they merge these three layers here and make it as just one. So they combined all the functionalities that application protocols, presentation, and session are doing. So with TCP/IP, they just like combine all these operations in just like one layer. So for here, for the transport, they just like made it as it is, and with the network, just make it as it is. And for data link and the physical, they combine these two into one network interface layer. So any task that was done on data link here, or anyone, or let's say any operation that was done, any operation that was done on the physical here, now both of these operations will be part of the network interface. That's why we said, like, when you have a modularity, then you can decompose or compose some of the functionalities together and combine them together to have like more flexible communication model. So how the transmission process is done? When a sender, or let's say you, as like an end user, trying to reach one website, okay, or trying to send an email, for example, you have your own data, and the communication model here is going from top to the bottom here. So when you have your own data, let's say when you are trying to send an email, then the designated protocol here is going to be SMTP, for example, or the mail protocol. If you are trying to access a web page, then the application protocol that is like specialized in this operation is HTTP. So you can imagine that we have, for each application, we have a protocol functioning here. So if you want to send, let's say, an email, then your data will be handled by this protocol. So for our example here, let's stick with just sending an email. So if you have your email here, SMTP, which is like one of the protocols used in the application layer, will take your data and add its own information, or let's say the rules for SMTP. Once it's done, then it's going to pass it down to the transmission layer. So in the transmission layer here, it's gonna be done like we are going to do something, we call it segmentation. We are trying to segment the whole data into small pieces of data. So the output of this operation here will have our data and the let's say the information added by the protocol itself, which is in this case SMTP. Then we are going to add some of the transmission protocols. In this case, since we are using email, we are using TCP protocols here. Once it's done, it's gonna pass it down to the internet. So in the internet, it's gonna add to the packet. It's gonna add how this packet must be forwarded, or what is the path that your packet should take. As you can see here, it's just like it's gonna add extra piece of data, which is related to the internet here. So once it's done, it's gonna pass it down to the network, where it's gonna add some extra functionalities to the whole frame. So in this area, in the transmission, we call it segment, and on the internet, we are calling this the output packet, and the output of the network is called frame. So in this case, it's gonna be sent through the wire or through the wireless to the destination. Once these frame are delivered to the destination, each layer here will take its own data and pass it up to the second layer. So in this case, the network will take the things that it's designed or send it to the network. And the internet will take the information of the internet. And the transmission will take the information about the transmission. And the application will take the data about application. Then the user or the destination will have the, let's say, destination data. As you can see, here we have something we call it encapsulation. So the data is encapsulated with application protocol. We then encapsulate the transmission information, the internet, and the network. So in this case, when the sender is trying to send some data, we call it encapsulation. And when the user receive the data, we call it decapsulation. So each layer will take its own data only and pass the remaining to the upper network or the upper layer. So as you may notice that I mentioned many times protocols. What kind of protocols? What are the protocols? So if we wanted to define the protocol is a set of rules that regulate or govern how operation will be performed. For instance, browsing a web or sending an email. So since all the devices, let's say mail service, if you wanted to send a message or email from computer A to computer B, then these two should understand the same, let's say, language. For example, if we have two people, one of them who's talking about, or let's say, speaks English, and the other guy speaks French or Spanish, for example, and we wanted to make both of them communicate to each other. In this case, since they have no idea what the other individual are talking about, they will not be able to communicate. So to make it able, to make these two people able to communicate, you have to have at least a common language that they can use. So if both of them are using the same communication model, and most of the time you will find these people are using TCP/IP, then you have to have a specific language or a standard that makes all the commands that you are going to send from the source to the destination will be recognizable. Okay, so as I said, there is a specific protocol for each application to regulate and govern how the operation would be performed. So if you are trying to, let's say, connect to a remote host, then you might use SSH or Secure Shell. If you want to browse a web page or browse the internet, then most of the time you are going to use HTTP. If you are trying to upload some files through file transfer protocol, then you are using FTP. If you are trying to, let's say, send an email, then you are using either SMTP or POP3, for example. So one of the main things that a web developer should understand is the IP address. Here, I'm not going to talk about how to do like the networking or how to do the IP addressing, but I just like wanted to focus on the minimum requirements for you as a web developer to understand about the IP address. So the IP address, I can say like the IP address is like your cell phone number. If someone tries to reach you, then he would call your number. The same thing happens on the internet. All the communication will be done through the IP address. So if you want to access, let's say, uncc.edu, it's true that we are writing our names, or let's say the names UNCC in the browser, but when it comes to establish the communication, we are not going to use the name. We are going to use the IP address. So it's almost the same thing as, like, let's say, if you save my number in your phone as, let's say, Ali, Mr. Ali, for example. Okay? When you are trying to call me on my phone, you are not calling through my name. You just like used your name, or let's say used my name as a way to find or to match with the number that you are saving in your phone. But the actual communication will be done through my number. So the same here. If you are trying to reach to a website, then you are reaching to this website through the IP, not through the name. And we will see it in a moment. But the things that you need to understand about the IP address, it's 32 binary bits. Each, like, it has like 4 octets, as you can see here. This is the first octet, second, third, and fourth octet. Here, it's 8 bits, 16, 24, 32. That's why we said like it's 32 binary bits. Most of the time, you will see like 2 parts of each address. One of them, which is the network. For example, we can say like the first 3 octets here are the network address, and this one, or the 4th octet, is the IP address of the individual PC that you are trying to reach. Another important, let's say, protocol that a web developer should understand very well is domain name system, or DNS. Most of the time, people tend to like remember the names, but hard to remember the numbers. So if you want, as I said, if you're trying to reach me or to call me, it's hard for you to memorize my number, but it's easier for you to memorize the name that you saved me in your phone, right? So the same thing here happened with the domain name system. It's like a table that has the name and the matching IP address with this name. So let me show you something in here. If I do Bing, it's enough. You can see that the IP address for uncc.edu is 152 192.168.115.47.208. This is the actual, if I wanted to make a communication or connection from my PC to the server of UNCC, then this is the IP address it would be used. Where did I get this number? Actually, when you are trying to reach through the name, the communication system is designed to, let's say, query the DNS server and ask the server one question. What is the IP address that match this entry here? And this is how it's done. So, as I said, it's just like a table. It might not be just a table, but for now, let's assume it's just a table with two columns, the IP address and the domain name. So it's matched together, and that's it. So, as you would see here, these are the information that I showed you earlier. It's very important for you to understand that one IP address might be like designated for more than, let's say, domain name. Or in other words, we might have multiple domains that point to the same IP address. In this case, we call this as a shared hosting. So, for you as a web developer, what you should know, what are the foundation or the key concepts that you have to understand? The key concept here is the hierarchy of DNS. So let's say it's me. Let me try to write it in here. If we type www.uncc.edu, in fact, the domain name should be written this way. As you can see, the last dot here is true that we start writing from left to right, but when it comes to the DNS read the name from right to the left. So we call this the root, and then top level domain, then the domain name, then we call it the subdomain. So let's go here. As you can see, this dot here is the root level domain, and it's gonna be always like this. The last dot after the domain name, this is like the root level. Then we are moving to the top level domain, which is in this case might be com, gov, org, edu, net, tv, all these kind of top level domain. After that, we call it the second level domain, which is in most of the cases we call it the domain name, or this is like the website name. In our case here, it's called NTC hosting, or let's say UNCC. Okay, so in our example, edu is the top level domain. Here, UNCC is the second level domain. So the subdomain, one of them is www. This is like we call it subdomain. And we might have like subdomain. This is like the hierarchical of the domain name systems. This is like really important for you as a web developer to understand how to, let's say, the domain name are structured. This is like one of the examples that we have as a web developers to understand, to read it. So let's go with like one by one. So the domain name, it starts with the protocol. So that means like the request you are trying or the website you are trying to reach, the request will be sent through this protocol. So in this case, either we have HTTP, which is like just non-secure transmission, or we might have HTTPS. So either HTTP or HTTPS will be used to transmit your data. Then we have this colon /. This is just like the standard. Then we have the subdomain, and in most cases, www are used as a subdomain, or we might have something like, let's say, my.uncc.edu. My here is a subdomain. So the second level domain is what we call domain name, which is like the website name. So for example, UNCC, or let's say Google, Gmail, any domain name. So here, the top level domain, which is in this case .com, we might have like .edu as our like in our example. Here, the path to the file, where the file you are trying to access is located on the destination server. And when we are in the module of building web application architecture, we'll understand what do we mean by path to the file. But let's assume for now that we have a destination server here, and we have a client on the destination server where this file is located on the server. Then we will have the file name you're trying to access, let's say index.html. So the file name is here, in this case, index, and the file extension is HTML. In most cases, HTML, or let's say the file extension, is used as an indicator what programming language your web page are written with. Finally, we have this parameter, or let's say the question mark here, which means everything is sent after this one. These are some information. We are passing this information from this page to the next page. Most of the time, we are calling this one query string. So these are like explanation for each of these one. But one more thing, which is you have to understand, which is this one here. The last line here tells you that a query string is one or more pairs of values in a way like the structure or the form key equal value. So let me tell you, like show you something here. So let's say I'm trying to access to, let's say, index.html. Then I want to pass two parameters, let's say first name and I want to pass another parameter, which is last name. As you can see, all this stuff, we can call it as query string. And we can pass multiple, let's say, multiple variables. So I can also pass, let's say, role and instructor, for example. So this means we are passing these parameters to this web page. We have to have, like in this case, we have to have some logic to handle these parameters, to do some stuff with it, either to just do some query, or let's say you want to add it to database or whatever. But the most important thing here is to understand that these query strings are some parameters you are trying to pass to the file name you are typing here. Okay? So this is like the most important part, that you have to understand what's going on with it. So another important protocol in this case, which is HTTP protocol. Mainly, this is like the main protocol that we are using nowadays for browsing the web. HTTP stands for Hypertext Transfer Protocol. As like most of the protocols that built long time ago, security wasn't one of, let's say, the consideration when they built it. Because at that time, when they standardized this protocol, the main focus was how to achieve the communication part, not how to achieve the security part. And the development of these protocols and the adoption for a new version of it, it's not that easy. Okay, so what kind of information that I need as a web developer to understand and to know about HTTP protocol? One of the most important thing, which is like really important for a web developer to understand, is HTTP protocol is stateless protocol. What does stateless protocol means? It means that every request will be dealt with separately. So let's say you have a website and you have a login page. Okay? For the first time when you logged in to the web page, your request like have, let's say, your username and password, and the response is going to give you the results, whether your username and password valid or not valid. When you are trying to access another web page on the same server, since it's a stateless protocol, then like the server, doesn't deal with the second request as, let's say, a second request. It's always for the server. Any request coming from the client, it will always be dealt with as number one request. So I have no history about the previous request. So in this case, as a web developer, how to overcome this problem? Because as you can see, like in our modern applications, you will log in once and you will keep navigating the website all the time until you just like log out or sign out and you just close your browser. Other than that, it's going to be function. How do we overcome this problem as a developer? Long story short, we are using session and cookies to overcome these problems, and we will see it once we are building our application. But for now, we have to understand that the server always deal with requests coming from the clients as the first request. It has no prior history, or it doesn't have any history about the request coming to the server. So the way that HTTP protocol works is the client will send a request, the server will process the request and return back the response. Every time, as I said, it's going to be the same thing. And every time for the server, the request here, it's going to be dealt with as it's the first time I see a request from this client. Okay? So as you can see, like with HTTP protocol, we have two main parts, request and response. What we should have or what we should understand about HTTP protocol, especially for the request. Usually, HTTP use some methods or something we call it actions or verbs. These actions is trying to direct, or let's say tell the server how to deal or how to process this request. So for example, let's say one of these requests is GET. When you send in your request, and this is a GET request, the way that the server deal with it is completely it's completely different than the way it's gonna be dealt with when you are sending post or update or delete. So there are like many request verbs that HTTP protocol supports, but for now we have to understand, like, if you are trying to just like navigate or browse any website, the default and the most common request type is GET, as we will see in a moment. If you are trying to to send some data from your client, let's say a registration for the course, or you want to let's say fill out some application, for example. In this case, the web page will use post for sending some of the data or update, for example. Okay, let me try to show you here how does this one work in action. So let's say first let's right click in here and choose to inspect. Let's see the networking. So we have nothing in here. Let's try to access. As you can see, these are all the requests that we have, that it's been sent from our PC to the ONCC. Let's say this one here. Let's try to expand this one a little bit. As you can see, this is the request URL, and this is the request method. And as you can see, this is the IP address for this specific resource. As you can see here, this is a request, and this is the response that it comes from this, let's say, website, which is UNCC. But the most important thing here is the server will be dealing with this request based on the request method or the verb that we are using. As you can see here, there are like many parameters that it's been sent. As you can see, the first parameter, expire, AI, all these are some parameters sent from my, let's say, client to the files is called video play pack. This is like the most important thing that you have to understand about this request method. Okay, so for the response, when it comes to the response, the browser should understand how to deal with the response or how to process the response. Let's say if you're trying to access let's say a resource that is not found on the server, how the server should react to this request. And when the response comes to the client have to understand how to work with or process this response. So the response, there's something called response code. The response code is used by the browser to understand what happened to your request. So this code is about, like, let's say 3 digits in this format. So the first digit here, which is like the left, on the leftmost here, means the category of this message. We have 5 categories, as we will see in a moment. But the first one from the left is like indicator what category this response belongs to. And the second 2 here, this is like the error number or the response number. So these are the categories we have. If the first number from the left has the number of 1, This means this is just like an informational message from the server to the client. If we have a response code that starts with 2, that means our request has been processed successfully. If we have a response message that starts with 3, that means it's done, but there is some redirection message that the client should do. Let's say if we are trying to reach a resource, but this resource has been changed or moved from one location to another location, then the response should have this kind of responses. If the response message code starts with 4, that means there is error on the client side. When we say error on the client side, usually the website or the file name you are trying to reach is not written in the right way. In other words, you are trying to reach not found web page, or page does not exist on the server. When you are facing a response code that starts with 5, that means there was no problem with your request, but the server has some difficult times when it comes to processing your request. So most of the time, any message that starts with 5, it means that there was a problem on the server and the server was unable to process your request. Let me show you here. As you can see here, the status code is 200. That means our code, or let's say the response, was successfully processed. As you can see, all these requests, as you can see, it's all okay. And you can see, like, at any page, you can see what kind of response. These are like the data that's per response. As you can see here, since it's HTTPS, all these data are encrypted, so you cannot just like read it by naked eyes. Okay? So another important factor that a web application developer should understand is which protocol from, let's say, transmission layer I should use. So HTTP is one of the applications protocols, right? The transmission is one, like, either we usually have TCP or UDP. We might have some other protocols, but the most common are TCP or UDP. So what's the difference? As a web developer, you have to understand what's the difference between TCP and UDP, and when you should build your system on the top of TCP and when you have to build your application on the top of UDP. So let's start with the TCP. Usually, as you can see here, TCP is usually called connection oriented, which means it will like the client will send the data to the server, and the server will send an acknowledgement that the message 1 has been received. As you can tell, TCP might be reliable, but the drawback of TCP is the speed. Because like for each message you are trying to send from the client to the server has to acknowledge. If the client doesn't receive an acknowledgement on the message that he sent, the client usually would resend the same message. That's why we said like TCP is connection oriented. That means it creates a connection or establish a connection, which usually we call it 3 handshake communication. Establish the communication before sending any data. And for each data that you send, we have to acknowledge. When we say acknowledge, it's not just like receiving. It should be received in the right way. So let's say in TCP, we have something we call flow control, which means I have to check like the received message, it's not corrupted. So that's why we say TCP is more reliable, but it's slower than UDP. So if you have like an application that you want application with the high reliability, then TCP might be a good option for you as a web developer to build your system on the top of it. But on the other hand, if you are okay with missing some data, for example, if you are okay with, let's say, not all the data that you send, some of them might be corrupted, some of them might not reach to the destination. So a good example about this is using like real-time data, let's say from sensors, or even like with streaming services. Sometimes when you are working with like stream services, you don't care about let's say the accuracy of data. As long as most of the data are delivered, then you should be fine. That's why when you are trying to let's say watch something on YouTube, sometimes you will have like big pixels. That means there's some corrupted data with the stream. So as you can tell, UDP is faster because it doesn't require any acknowledgement. When you want to send something, then you can see here, message 1 is sent, message 2 is sent, message 3 dropped or lost. The server doesn't care if it's dropped or not. Okay, there's no acknowledgements. That's why UDP usually is like connectionless, because it doesn't establish connection before sending any data. This is the first thing. The second thing, UDP is considered to be faster and less reliable. In most cases, as I said, when you are trying to stream some data, then UDP, it's gonna be a good choice. If you want to just like send some data, it's not that big, then TCP would be a better option since it has some validation. As I said, if you are trying to reach to a server and you are not able to reach to this server, how you check whether you have a connectivity issue or something else? As a developer, there's a command from like it's available like almost on all operating system, let's say on Linux, Mac, or Windows. There's something called ping. Ping is used to check the connectivity. Most of the time, if you wanted to check like whether you are connected to, or you are able to connect to the destination, you will use ping command line. So let's say, let's try it here. If I wanted to reach to this, I want to reach from home PC to ISP2 PC1. Or let's say, let's just make it for here. So from the command line, I can say ping, then 10, 10, 7, 1, for example. As you can see here, there is reply. That means I can send data from this PC here to this web server. Or in other words, I have a connection from here to here. Or I can connect from here to here. Okay? This is like the basic stuff. If you want to see like in life, how does it work? Let's say Let's turn this simulation here to see how it's going to be moved from one place to another. Let's do the ping again. Let's see how does it work. As you can see, right? This is like how does it work. What if we are trying to reach to an IP which is not found? Let's see how does it work. Let's redo it again. Let's go here. It's gonna go to the designated, as you can see here, there's no IP because the IP number or the IP address that we are trying to reach is part of this yellow network. So once it's reached here, as you can see, it's trying to send ARP, which is like completely different protocol. It's trying to understand whether this application or let's say this IP is there or not. That's why if we turn this to real time, you will see the response here. It's going to be request timed out. That means it's trying to reach to this IP, but seems that the IP that you're trying to reach cannot respond back to the request to the client. Okay? So this is like checking connectivity. It's important for you as a web developer to understand and to check whether you are able to connect to a specific resource or not. Another, let's say, skills that you need to, as a student and as a web developer, you need to understand is how to trace your packet. Once a packet comes out from the client, how you trace it to the destination. Let's say from the source to the destination. Because in most cases, if you are building a web application and there is a problem with the connectivity, you as a web developer, you will be the first one who will be asked, where is the problem? No one knows where is the problem. They will come to you, your application is not working. And you as a web developer, if you don't have let's say a team who can handle this stuff, you have to handle it yourself. So you have to understand what's going on. Another scenario, which is like really important for you to understand what's going on, is if you are your application is in, let's say behind the firewall, for example, and you wanted to check whether is it accessible from somewhere or not. You have to know if your packet is blocked by someone or not. So in this case, we usually use something we call it trace route. Okay, let me try to see what's going on here. So if I want to trace my packet that goes from here to here, I want to see what are the hubs that my packet used to travel from the source to the destination. So let's say from here, I would go with trace route. This is like on Windows. On Linux, you may use tracert. I believe this is in Windows. Trace route on the other systems. So what I'm trying to do is try to reach to this web server. So this web server address is 10.10.7.1. Let me show you here first How does it work? As you can see, the first hop, it goes from here to this router. This router doesn't know where this address belongs, but he knows that if I have something that I doesn't know, just pass it to this router. So this router will do the same thing, because this one, as you can see here, the network is 10.10.2. This one will send the data to the second router. Then the second router will send it to here. Here, when it arrives here, then as you can see, it will come to this one. If we want, we can just like turn on the simulation here, and we can redo the thing. And let's see. This is like because I have many stuff in here. But anyway, this is how it works, how to trace your packet. So as you can see, this is the first hub, second hub, third hub, fourth, and fifth is always the destination. Okay, so this is like the most important skills as a web developer you have to understand from the networking perspective. This is all for this module. I'll see you in the next module. Thank you.